we want to continue working with discrete probability distributions. So for example 4, we have the number of customers in line at a supermarket express checkout counter. So we have 0, 1, 2, 3, 4, and 5. The probability that 0 people are in line is 0.10, or 1/10. The probability that 1 person is in line is 0.25, or 25 hundredths. 2 people is 0.3, 3 people is 0.2, 4 people is 0.1, 5 people is 0.05. Is this a true probability distribution? When we're asking if it's a probability distribution, recall the requirements for this. First of all, we cannot have anything that is a probability that is less than 0, a negative value, or greater than 1. So looking here, yes, we're okay there. The second rule is that the probabilities must add up to 1. Probability of x, we add those up, and what do they equal? So when we add 0.10 to 0.25 to 0.3, 0.2, 0.1, and 0.05, they add up to 1. So yes, this is actually a true probability distribution. Then we want to find the probability 2 customers are in line. So that's the probability of 2. Well, 2 customers being in line is right here. The probability that 2 customers are in line is 0.30. Then we want to find the probability that no more than 1 customer is in line. So probability no more than 1. Well, if you think about it, no more than 1 means, okay, I can have 0, or I can have 1, but I can't have anything else. So probability of no more than 1 customer in line is the same thing as saying the probability of 0 plus the probability of 1. So we have 0.10 plus a 0.25, which gives me a 0.35. The probability that no more than 1 customer is in line is 0.35. Find the probability no one is in line. Well, looking at our table, no one being in line is my 0. So probability that no one is in line, no one in line, is the same thing as saying probability of 0, which is going to be 0.10. Now we want to find the probability that at least 3 people are in line. So the probability at least 3 people. Well, when we think about 3 people, we want at least, so that's the smallest value, so I want at least 3, and I can have 4 or 5. So we're going to say that this is going to equal a probability of 3 plus the probability of 4 people plus the probability of 5 people being in line. So the probability of 3 people being in line was 0.20. The probability of 4 people was 0.10. And the probability of 5 was 0.05. I add these up and I get 0.35. So the probability that at least 3 people are in line is 0.35. A probability distribution actually describes the population, because we have to look at it as a whole. It can't just be the sample or anything. So when we're looking at probability distributions, we also want to look at probability histograms. Probability histograms are those in which the horizontal axis corresponds to the value that the random variable can take on, such as 0, 1, 2, 3. The vertical axis represents the probability of the value of the random variable. So this is like saying, okay, here are my values that I can get. This is my probability of x, or my relative frequency is the same situation. So let's look at an example of a probability histogram. So this probability histogram represents the number of live births by a mother who is aged 50 to 54 years old who had a live birth in 2007. So in 2007, these ladies had live births. The number of children, so if this live birth in 2007 was her first child, we had a 0.313 chance. If this was her second child, it was 0.244, and so forth. You'll notice that we drop off here by the 7th child, so if the live birth was her 7th child, that's going to be 0.021. So looking at this particular table, what is the probability that a randomly selected 50 to 54-year-old woman who had a live birth in 2007 has had her 4th live birth? So that means that this was child number 4. So this is the probability of it being 4, which is right here, 0.099. So we have the probability, and I'm still missing a 0 there. Let me go back and put in another 0. There we go. So the probability that the randomly selected mother who had a live birth in 2007 has had her 4th live birth is 0.099. What is the probability that a randomly selected 50 to 54-year-old mother who had a live birth in 2007 has had her 5th or her 6th live birth? Okay, so this is the probability of 5 or 6. So that's the probability of 5 plus the probability of 6. So 5 was 0.054, and the probability of 6 was 0.043. We add these together, and we get that the probability that the woman has had her 5th or 6th live birth is 0.097. Let's look at part C. What is the probability that a randomly selected 50 to 54-year-old mother who had a live birth in 2007 has had her 6th or more live births? So this is going to be the probability of 6 or more. Well, if we look at it, 6 or more, that's going to be 6, 7, and 8. So we have the probability of 6 plus the probability of 7 plus the probability of 8. Well, probability of 6 is 0.043. The probability of 7 is 0.021. And the probability of 8 is 0.061. We need to add those together. When we add those together, we get 0.125. The probability that a randomly selected 50 to 54-year-old mother who had a live birth in 2007 had her 6th or more live births is 0.125. Let's look at example 6. We want to flip a coin 3 times, and X is the number of heads. So first of all, we need to look at the sample space for flipping a coin 3 times. So if I look at flipping the coin once, I can get a head or I can get a tail. On the second flip, I can get a head or a tail, a head or a tail. The third flip, I can get a head or a tail, head or a tail, head or a tail, and a head or a tail. So whenever we're looking at all of our probabilities and our possible outcomes, we can get 1, 2, 3 heads. So that's a head, head, and head. We can get a head, head, tail, head, head, tail. We can get a head, tail, head, head, tail, head, head, tail, tail. Then we can get a tail, head, head. We can get a tail, head, tail. We could get a tail, tail, head. Or we could get a tail, tail, tail. So now this is my possible outcomes. Looking over here, we want X to be the number of heads. So if I look at this, my number of heads can be 0, 1, 2, or 3. So I have 0, 1, 2, or 3. Where if I want to go through the probability of these, I have a total of 1, 2, 3, 4, 5, 6, 7, 8 possibilities. How many possibilities is it if I get 0 heads? Well, 0 heads is strictly here. So that's 1 out of 8, or 0.125. Well, the probability of getting 1 head is going to be, here's 1, here's another 1 head, and here's another 1 head. So that's going to be 3 out of 8, which is 0.375. Getting 2 heads, here's a 2 head, here's a 2 head, here's a 2 head. That's 3 out of 8 again, which is 0.375. The probability of getting all 3 heads, I only have 1 of those shots, so I've got 1/8, which is 0.125. If we add these 4 probabilities up, we should get 1, because recall that all the probabilities have to add up to 1. So we have created our probability distribution. We have to find out what are all of our possible outcomes, and then how many heads can we get. We can get 0, 1, 2, 3. And then we have to find the probability of getting each of those. Now we can create a probability histogram. So I'm going to draw my vertical axes. I'm going to draw my horizontal axes. My horizontal axis is going to be 0, 1, 2, and 3. This represents the number of heads that we get. So this is number of heads. Now my vertical axis, I need to put the probabilities of those on there. So if I look at this, I need to go from 0 at least up to 3.75. So if I do 0.1, 0.2, 0.3, 0.4. So here's 0.4, not 5. That should be a 3. 0.3, 0.2, 0.1, because this one is 0. Now then, the probability of getting 1 head was 1 time out of 8, which is 0.125. So I'm going to come up 0.125. I'm going to draw my box. Since these are discrete, recall that your value is in the center of the box. The bars still have to touch, but our value goes over the number. Now for 1 head, it was 3.75. So I'm going to come up 3.75 and go over. 2 heads was also 3.75. So I'm just going to draw a box that extends. There we go. And then 3 heads was 1.25 again. And there we go. We have now created a probability histogram. I recommend that you work on trying to create probability distributions and probability histograms. Let me know if you have any questions.